Hello and welcome to today's lesson, Graphs of Sine and Cosine with Transformations. I'm your teacher, Giselle White, and today we're going to talk about the ways in which we can interpret a graph, or in this case, an equation of sine or cosine, in order to get the points of a graph and figure out all of the translations and transformations that happen from its original starting point. To kick us off, I want to touch on what an untransformed sine and cosine graph looks like and what those points of reference typically are. So we know that without transformations, a sine graph is going to look like similar to the letter N, and the cosine graph is going to look like a U. So this is with no reflection over the x-axis and no transformations being applied to it. The y values are as follows for both sine and cosine. And we will move on to how to find the different translations from these basic untransformed graphs. So just a quick overview of the different types of transformations that are possible in sine and cosine graphs. There's vertical translations, horizontal translations, reflections, vertical shrinking and stretching, and horizontal shrinking and stretching. So like all points and reference of math, there is a formula or a typical equation to look out for when it comes to the graphs of sine and cosine, and it is typically going to be in that y equals a sine of k times x plus or minus b plus or minus c, and that can be in a sine or a cosine graph. And this is where the variables a, k, b, and c represents transformations to the graph. So any change from the original base form of a sine or cosine graph will be known as a transformation. This relates to A being the amplitude, our B variable representing a phase shift, our C variable representing a vertical shift, and our K variable representing a period. To solve, you will look at calculating the amplitude by finding the absolute value of A. To calculate the phase shift, if B is negative, that'll be going right B units. And if B is positive, that is going left B units. A little counterintuitive with that one. And for vertical shift is always going to be at the end of the equation of a graph of cosine or sine. And if it's positive, that's going to be up C units. If it's negative, that's going to be down C units. And for our period, in order to find the period of a transformed function, you will do 2 pi divided by k, where k represents the period. So now you're probably wondering, how do I solve this really though? So that's what we're going to be working on next in our next 2 examples of sine and cosine equations, and kind of interpreting the equation in order to find the ordered pairs of a graph. And the simplest way I can explain being able to solve these kinds of equations is you will be utilizing our information from the first slide about untransformed sine and cosine graphs in order to apply each variable transformation and get the new x and y values. So for our first example, we have given the equation of a sine/cosine function, determine amplitude, phase shift, period, and vertical shift of the function. List the points of the function. So we do have the function f of x equals 5 cosine times 3 times x minus pi plus 8. Right here. So the first thing we're going to find is the amplitude. We know from earlier in our lesson that amplitude equals the absolute value of A. And in this equation, our A is represented by 5. So amplitude equals absolute value of 5, which equals 5. Perfect. Next, we're going to determine the phase shift. So in order to find the phase shift of the function, we know that is represented by our variable b. And in this case, our b is represented by the symbol pi. And since it does have a minus sign in front of it, that means that our phase shift equals right pi unit. Next, we'll identify the vertical shift. And that one is represented by our variable c, which is always on the outside of our parentheses. And in this case, we have a plus sign before our c, which represents that we're going to be going up. And finally, we're going to identify the period of this graph. And we know that our period is represented by 2 pi over k, where k in our case is represented by 3. So in order to find the period, we're going to plug in k, and that is going to be our period, since it is already reduced. So these are all of our elements as of right now, and we're going to utilize these 4 pieces of information in order to find step 2, which is the points of this graph. All right, so to find the points of the function, we're going to apply the transformation, which I have highlighted all of our found variables. And our first step is going to be to multiply our x value times 1 over k. So what that'll look like is 0 times 1 over k, which is 1/3 for us. So once we do our first step, which is multiply our x value times 1 over k, we're going to take the value we get from that and move to step 2, which is our plus or minus b, which in our case is going to be plus pi, since it was a positive. Now that we've figured out step 2, we have our updated x values in this second column. Next, we're going to find our y values, and in order to do that, we will need to use our untransformed cosine values, and then we're going to transform them with our a value and our c. And that is going to look like, as we know, untransformed cosine, x is 1 for 0, and then for pi over 2, 0, -1, 0, 1. always verify that you're using the correct ones first. Cosine and sine. And then we'll go into step number 3, which is to multiply by the amplitude. Now that we have our new values of after being transformed by our amplitude, we can take those values and transform them further by plus or minusing our c. In this case, we'll be adding 8 to each value that we obtained. Once we apply the transformation of c by adding 8 to each of those values, we now have our y values, which brings us to the next step of listing our ordered pairs. So that our completed solution will look like this, with our amplitude of 5, phase shift going right pi units, vertical shift of 8 units, and the period of this equation is 2 pi over 3 for every complete cycle of this equation, and the ordered pairs are as follows. Alright, so for our second example, it says, given a function of sine, identify amplitude, phase shift, vertical shift, and period, as well as list the ordered pairs of the graph. So we'll jump right in. When we're looking at the equation of this graph, we see that our amplitude is -3. And that actually means it's going to be the absolute value of -3, which equals 3. Phase shift, we see a plus sign in front of our b value, and that's a little counterintuitive. With the positive, we're going to go left 2 units. Now for the vertical shift, has a positive in front of it, and it's always going to be after the parentheses. Always forget my second parenthesis. And since it is a positive, that's going to be up 5 units from its original point, untransformed. And then finally, we're going to look at our period, which we know the period is equal to, for untransformed graph, 2 pi, or in our case, it's going to be 2 pi over k. In our case, our k is pi over 4. So in order to find the period, we're going to do 2 pi over 1. And we're going to times it by the reciprocal, because we did, so before we were just multiplying by the reciprocal, so we do 4. Pi's are going to cancel out, and that is going to give us 8 as our period. So since we have found all of our transformations, we'll jump right into finding our ordered pairs. And of course, we're going to start with that first step, which is multiplying our original, or our x values, by 1 over k, or in our case, it's going to be 1 AE units, and that is the k we got from our period function. So now that we have our first transformation, which is multiplying by our period, we will now move those values into step 2 and subtract our b. Alright, and after applying our b transformation, we get our new x values in the function. And next we'll move on to transforming, or using the untransformed values of sine in order to find our new y values. In our first step, we'll do that by applying the amplitude to all of these untransformed sine values. And now that we have applied the amplitude to all of those untransformed sine values, we'll take that final step by applying our C value in order to get our final y's. And this brings us to our completed answer of this sine equation with an amplitude of 3. Phase shift is left 2 units, vertical shift up 5 units with a period of 8. And the ordered pairs of these transformations of the graph are as follows. And that is all I have for you today. I hope this helped. Be sure to give yourself a pat on the back for doing some examples of sine and cosine graphs with transformations. And I hope you